All right. Good morning, everybody. Today is the 23rd of February, Tuesday. We're on e-learning week actually, so this is week 7. So as per e-learning week, we'll have everything online. You guys can continue to watch the online lectures. The tutorials have all been moved to online self-learning, basically watching the previous tutorials recorded. In today's lecture, I'm going to go through the 2019 exam paper, and we are going to tackle question 2, right? So in the exams, you only have half an hour to do this question, but in this tutorial, we'll do it about in 45 minutes. Okay, so let's see the exam questions. So as you all know, you should be able to download the exam questions. So download this one, April, May 2019, and let's discuss question 2. Now in question 2, we began with the question that we have a repeating sequence 1240, 1240, and x0 is 1, meaning that we start with this number 1, and then it repeats, and then we are asked to find, interestingly, the DTFS coefficient, and then later on I will show you the DTFT coefficients as well for the same sequence. Okay. It asks us to label the x-axis in terms of angular frequency as well as y values. So he didn't ask us to label the x-axis as k. Okay, so let's take some time to just do this question first. All right, let me write down. So this is xn. 0, 1, 2, 3, 4, 5, and so on. And this is n. And this is x of n. And now I change the color, and then x0 is 1. Then we have 2. This is 1. This is 2. And x2 is 4. This is 4. And then x3 is 0. And then we repeat. And so on. So we see that this guy, n equals to 4, is a repeating sequence. And n equals to 4 is the fundamental period, because xn is always equals to small n plus 4. Okay, once we have this, then the question asks us to find DTFS. And then to find DTFS, when he asks us to find DTFS, he's asking us, he's asking us to find the CK coefficients. Now, what is CK coefficients? CK's coefficient is, you must memorize this equation, or you have one page of cheat sheet, so you must use that cheat sheet to write down the equations. No equations will be provided for the quiz. In the exams, if you look at the exam papers, we did give you some equations, but in the quiz, there will be none. So it will be 1 over n, summation of n equals to 0, n equals to 3, because there's only one period. And then we have x of n, and then e minus j, and maybe just maybe you would like to write it this way, okay, which sometimes we suggest omega naught k omega naught n. All right, so why do I put omega naught? So what is this guy? Omega naught is equals to 2 pi over big N. And what is n? This is the n. And you realize that what Fourier says is this. Fourier says that all we need is complex exponential. This is complex exponential with frequency k omega naught to reconstruct our signal. Okay, because in the synthesis equation, x of n, you'll realize that the synthesis equation, now I will share the code with you on the slide, sorry. In the synthesis equation, can you see this part, which is the synthesis equation? He says that the original xn can simply be reconstructed by complex exponential of k omega naught frequency. Okay, all the k's, yeah, k equals to 0 to n minus 1. But you can reconstruct xn by weighted, because ck is multiplying by this complex exponential of this frequency. Okay, hence that's why 2 pi over n is a very important number, because 2 pi over n tells us the fundamental frequency of the signal, the complex exponential that we're going to use. Okay, so now you'll be wondering what is the k that we are going to deal with. It will be 0 to n minus 1. So you can then, therefore, you need to do C0, C1, C2, and C3, because 3 is equals to n minus 1, because big N is, in this example, 4. Okay, so you must get all these numbers by heart, and then now we can deal with C0 is equals to 1 over n, which is 4, and then we do a bracket, and then now I'm going to expand x0 e minus j omega naught, and then this, remember, is k equals to 0, so this is k, and then here is little n equals to 0, so this is times n equals to 0, plus x of 1, so this is n equals to 1 e minus j omega naught, and then k still remains 0, and then n is 1 here, because this one is equals to this one. So it is always, that's why this equation is very confusing, because simply because we have omega naught here, we have k here, and we have little n here, and you must be figuring out what is the little k and little n. And then of course we can do the second one, and then e minus j omega naught 0 2, and then the third one, e minus j omega naught 0 3. All right, you realize that this question is very nice, because the question is our x3 is 0. So if our x3 is 0, this guy goes to 0, because simply because this x3 is equals to 0. So there's nothing to do with x3. So the equations that we need to solve is this guy, and this guy for C0. Okay, now the rest is simply mechanics. Okay, the mechanics, because you have to multiply a real number. In our example, x0 is 1, x1 is 2, and x2 is 4. So you have to multiply this number with some complex exponential. So it results in a complex number in exponential form. You have to add it. And the problem with adding complex exponential is that you must convert all of them to rectangle, unless you have a calculator that can add in polar form. So I will pause now and ask you. Right, so the trick is, if you have a calculator that can add complex numbers in the exponential form, that will be easy. So let me just do this for you. Equals to 1/4, then the first entry is 1 multiplied by e minus j. Omega naught times 0 is 0, so this is 0. The second number is 2. Then this one is e minus j0. This is easy, because, and then the third number is 4 e minus j0, and the last number is 0 times e minus j0. And then the answer, of course, for this guy is relatively painless. So this is 1 plus 2 plus 4, and the answer is 7 over 4. And 7 over 4 is a real number. So this is, so if you really want to, you can write it this way. So you realize that the imaginary part is 0. Okay, and the other way you can write it is 7 over 4 angle 0. This is in the polar notation. And then if you want to write it in the rectangle form, is 7 over 4 ej0. So this is another what do you call complex exponential notation. So you see that we can write three ways, huh? The rectangle form, the polar form, and the complex form. Typically, we want you to write it in the complex form because we want the magnitude. This is the magnitude, and this is the face of the angle. Okay, now we just try with C1. C1 is equals to, again, is 1 over 4. The first number is x1 is 1. The second number is E minus, okay, let me, minus J. Now, I want to remember omega naught. Omega naught is 2 pi over 4 is pi over 2. So it's E minus J pi over 2. K is 0. N is 0. Oh, no, K is 1 now, huh? K equals to 1. So this is 1. So K equals to 1. And then plus 2E minus J. You guys are seeing my screen, right, guys? Can someone type and tell me? You are seeing my screen? Yes? Okay, good. Second one is minus pi over 2. And then K is still 1. And N is now 1. So remember, this is K and this is N. Then plus 4, E minus J pi over 2. K is still 1. N is now 2. And the last one, 0. And in fact, once we see a 0, we don't even care about this little guy here. And then we have done. Okay, so now let's work this out together. 1 over 4. 1 times, so this is 1 EJ0. This is easy. This reduces to 1 multiplied by 1 plus 2 E minus J. So all this guy reduces to pi over 2. Now what does this reduce to? 2E minus J is 2 angle minus pi over 2. This is in polar form. And then in rectangle form is, anybody? Can someone tell me what's the rectangle form of this? Please. You all must do this by yourself, right, in the exam. 2E minus J pi over 2, correct? Yeah. What is in rectangle form? No, I want in the rectangle form. This is the complex exponential form. This is the polar form. This is the rectangle form. Okay? Can? The polar form is like, it's just a shorthand for. Okay, and then plus. Now, what is 4E minus J pi? Right? This reduces to pi. So this is a complex exponential form. Let's reduce this to 4 angle minus pi. And guys, what do you think this is? This is minus 4 in rectangle form. Yeah, very good. So now we're done. And then therefore the answer is 1/4 1 minus 2j minus 4. And the answer is, what's the answer? Minus 3 minus 2j divided by 4. Okay, did I get it right? It's minus 3/4 minus half, correct. So then we get this answer. Minus 3/4 minus half j. And this is the answer in rectangle form. But remember, we don't like things in rectangle form. So we convert it into polar form. And the answer is 0.9014 angle minus 2.55. Or if you prefer, 0.9014 E minus J 2.55. Whichever is the same. So these three are the same number in three different forms. Okay, so you'll see that we took a few steps to get from the equation of CK all the way to C0 and C1, and then the rest is, of course, very mechanical. You have to deal with C2 and then C3. I'll tell you the answer now for C2. C2 is equals to 0.75 angle 0, and C3 is 0.9014 angle plus 2.55. So you'll be wondering, where have you seen the number before? You realize that C3 is complex conjugate of C1. All right, So then, so therefore, once you have these four numbers, the 6 marks question, right, asks you not only to calculate these 6 numbers, but to plot it. So let's go and plot it now. So we are going to plot CK magnitude and the angle CK versus, not K, but versus the frequency. So first we draw the frequency. So this is the magnitude of CK. This is the frequency omega. This is omega. And this is the angle of CK. The first C0 is 1.75 angle 0. So let's get, so the magnitude is 1. So magnitude of C0 is 1.75. The angle of C0 is equals to 0. So let's draw this. 1.75 is here. 1.75 because this is the 0 frequency. Okay. So then you say, why is C0 at the 0 frequency? All right. But you just pause for a little while. So this is magnitude of C0. This is angle of C0. What about C1? Okay, I'll just put here 1 first. But you say it's omega, not 1. Actually, it's 1 times and the omega naught. What is omega naught? 1 times 2 pi over 4, which is equals to pi over 2. So you realize that actually C1 belongs to pi over 2 because C1 is 1 times omega naught. The frequency of interest is at 1 times omega naught, 1 times 2 pi over n. And big N is 4, meaning pi over 2. What about C2? C2 is for frequency 2 omega naught. Therefore, it's 2 times 2 pi. For this 2 is 2 pi over 4, and therefore is equals to pi. Then the last guy, if everyone is transversing by pi over 2, this guy must be 1 over 5 pi. And the next guy, pi, 2 pi. Okay, so now you can see x-axis being the frequency and where they are exactly. So we are going to plot also for pi over 2, pi, 1.5 pi, and 2 pi. Now, let's continue with C1 now. So we have C0. What about C1? C1, we have calculated upstairs, and the answer is 0.9014 angle minus 2.55. So let's draw the 0.9014, which is about here, I guess. 0.9014, and the angle is minus 2.55. So I should go up and go down, minus 2.55. What about the third one? Let's change the color. C2 is equals to, I calculated is 0.75 angle 0. So 0.75 is here. Angle 0 is here. And then the last one, I calculated C3 is equals to 0.9014 angle plus 2.55. You realize that it will be, so this is 0.9014. So in fact, these two guys are identical in height. And not only that, the phase plus 2.55. They are complex conjugate of each other. Okay, so this is the answer, and you get 6 marks. All right, for this question. So let's review the question again and see what it asks us to do. You are given the repeating sequence 1240. You are to find the CTFS coefficients, which we have done, and we are going to sketch the magnitude and the phase spectrum, which we have just done. And then we wanted the x-axis in terms of angular frequency as well as the y-axis value. So I'm asking you to put all these y-axis values here, and then the, what do you call that? The x-axis is not k, but in the frequency. Okay, so we are done with question 2a. All right, so let me pause now, and then I'll take questions first. Okay, pause. Okay, Raymond asks, given that we have found CK, can we have the closed form of Xn? So what is Xn? Xn, Fourier says, if you have already found all the CKs, all you simply need to do is to do summation of CK, k equals to 0 to n minus 1, e plus, okay, not minus, j, 2 pi over n kn. Now, so what do we do? What is CK? What are we going to do? We're going to do C0 e j 2 pi over 4. K is 0, and this is n. Then the second one is plus 0.9014 e minus j 2.55 e plus j 2 pi over 4. K is what? K is 1 because this is C1. So K is 1, n plus the third one is 0.75 ej0 ej 2 pi over 4. K is 2, small n. And the last one is plus 0.9014 e plus j 2.55 e plus j 2 pi over 4. K is 3. So this guy, K is 2, then n. Can you see now? So this is Xn. So this is the closed form solution to represent this guy, which is 1, 2, 4, 0, and then repeats. Okay, in fact, you can plug this equation in and generate this sequence. No problem at all. An example, so that closed form is DTFS. I don't understand. Raymond, can you explain what you want? All right, the second question is this. The first part is, it says that I give in you a time signal, continuous time signal. I sample at 8,000 hertz. What is the expression for Xn? Okay, so this is from the first part of the tutorial 1. Okay, let's try. X of t is equals to minus 2 plus 1. You guys are looking at my screen, right, guys? Yes, no? Can someone type for me? Yes, thanks. Minus 1 cosine. Okay, let me see whether I have resumed recording. I have resumed recording. Okay, good. Cosine 2 pi 1500 t minus pi over 6. So the idea of this equation is that you have to be observing t. So this is t and this is t. There's no t here, okay? So the only thing that is going to change is t. So when we are going to sample, so how often do we sample? We sample every big T, the sampling period. The sampling period is now sampling period. The sampling period is 1 over f. Okay, and the sampling frequency. And we are going to sample at 1 over 8,000. That means in 1 second, we're going to sample 8,000 times. Okay. All right. And when are we going to sample? Every t. So now x of nt. Okay, so from t becomes nt. So if you really want to look at it, it'll be x of 0. The second time is 1 times big T. The third one is 2 times big T, and so on. At when? So this is the x 0 second. This guy, x at 1/8000 of a second. This guy, the second 1 over 8,000 of a second. So actually, you realize that all we are doing is this is t, and this is a signal of interest. We are sampling at, so I'm going to draw for you now in red. We're sampling here. The second one we're going to sample is here at 1 over 8,000 of a second. The third one here, 1 over 8,000 of a second. Okay, and then the third one is here, and so on. So you figure out that, oh, okay, the expression is nothing but replacing small little t with nt. So what will change? This guy will change. So I'm going to write the equation now for you. X of nt is equals to minus 2 plus 1 cosine 2 pi 1500 n divided by 8,000, because capital T is 1 over 8,000 minus pi over 6. And then we can reduce this to minus 2 plus 1 cosine. And then if you evaluate this expression, the answer comes out to be pi of 3 over 8 n minus pi over 6. And then suddenly you see, from a very complicated looking thing, it reduces to the digital frequency. Okay, so this guy is called omega, and omega is radian per sample because the unit is sample. Clear? So you must go through this. All right, so let's write the equation again. X of nt, and this is a 3 marks question, minus 2 plus 1 cosine 3 of 8 pi n minus pi over 6. Clear? Now, once you have this, the second part of this question asks, represent this by, let's get the question out. Represent this by 16-point DFT. Okay, although the question is asking for DFT, and DFT is not in the quiz, so instead, can I just deal with it as maybe DTFT? Can? So if I ask you, let's represent this in 16-point DTFT, then you can see, then actually this question is also related to the last question, which is how is DFT related to DTFS and DFT? Okay, maybe I should do it in DFT so that you guys wouldn't get confused. All right, let's see. DFT. Okay, let's deal with DFT first. DFT of XN. Why 16 point? So first is if we have a 16 point, we are basically asking you to calculate x0, big X1
Prof, you can't
until,
see.
sorry? Oh, you can't
Can't
see.
see it.
Oh, sorry. DFT until X15. Wow, so this is the pain, right, guys? So imagine in the exam, right? You are going to, if I'm going to ask you to calculate DFT of this, and then if you do it by hand, it will take you forever, and you can't do this. Okay, so don't fall into this trap. Instead, observe that we only have two signals in X and T. What are the two signals? One is frequency 0, because here, see, this is frequency 0 and is always 2. And another guy is cosine at frequency 3 over 8 pi. So once you understand this, then you realize that all these guys, most of them are 0, except frequency 0 and frequency, how many? 3 over 8 pi have value. Okay? And then if you realize that, then actually we're only solving for this guy and this guy. Actually, there's one more. We need frequency minus 3 over 8 pi. So you need to solve 3 guys, but these 2 guys are complex conjugate of each other, the CKs. All right, so the first thing is, where is 3 over 8 pi? Here, here, here. Which frequency is 3 over 8 pi? So if you remember that omega naught is equals to 2 pi over n, 2 pi over 16, pi over 8. Where is k for 3 over 8 pi? Answer is k must be equals to 3. So, therefore, we are interested in C3 and C minus 3. Actually, where is C minus 3, guys? C what? C0 to C15. So, I think it's C15, 14, 13. I always get confused here. Is it C13 or C14? 14, 15, 16. Yeah. Which one? C minus 3 and C3 is easy. Is it C13 or C14? Okay, guys, go and figure it out. So anyway, what we then do is that we know that we only have C3 and C minus 3 for the cosine wave. What about minus 2, frequency 0? Which frequency K, which frequency K is representing minus 2? And the answer is, of course, the kth harmonic equals to 0. So we therefore we need to solve C0, C3, and C minus 3 to represent our signal of interest, which is xn equals to minus 2 plus cosine. And then if I really want to write it, it will be 3 omega naught n minus pi over 6. Why omega naught? Because omega naught equals to pi over 8. Now, once you have this, it's quite easy because you can do minus 2 ej omega naught 0 n. What is this? Plus, and you represent this as sum of 2 complex exponential. And then you realize that you can now plot this way. You will have 0 for k. This guy is 2. See, this is minus 2. What is minus 2? Magnitude is 2. And in DFT, you must be multiplying by the little n here. So don't forget. To get minus 2, you must have phase is pi. So this is magnitude of CK. This is angle of CK. Actually, it's not, I shouldn't say CK. It should be big X 0 for the DFT values. Okay. Prof, for 2 pi, why? For 2b, why is it finding 2xnt and not xn? Same, xnt is xn. Shouldn't it be using 2 pi f over fs? Yes, it is 2 pi f over fs, correct? Raymond, so what's the problem? 2 pi, did I make a mistake? 2 pi f over fs? Is it here? You're worrying about this question? 2 pi f over fs? Then omega is 10 pi over 3. Is it? Really? Okay, let's try. You're talking about this one, huh? Okay, let's work out. 2 pi 1500 divided by 8000, correct? So the 0 is gone. 1, and then we have 40. So we have pi 15 over 40 equals to pi 3 over 8. Okay. N. Okay? Okay, any other questions, guys? So I got the first one. Now maybe I'll just tell you how to do the second one. 1, 2, 3. 1, 2, 3. So you realize that the second guy, all you need is a half times n. Later on, we'll figure out why the half. Here would be minus pi over 6. Minus 1, minus 2, minus 3. Here would be half times n. And here would be minus plus pi over 6. And then now I'm going to explain to you why we have these two guys. And the reason is this is expressing a cosine because we are doing half. You ignore the n first, okay? Half e what do you call it? Minus j, so plus minus pi over 6. This is representing half. This is representing this guy times e plus j. Then here is k equals to 3 omega naught n plus half e plus j pi over 6. This is representing this guy. This half is representing this guy. E plus j 3 omega naught n. Now, can you recognize this expression? Isn't this expression some cosine? Because cosine theta equals to, remember this equation? The Euler equation representing a cosine with sum of two complex exponential. And you realize that I have just broken down the cosine into sum of two complex exponential. Now, if you have problems following this argument, I'm going to show you where exactly you need to study. All right. Where is it? Here. So the question is the same, exactly almost the same as the exam question. Here only shows you one cosine and 8 samples. In this, I show you that actually the cosine and the sine are nothing but phase shift of each other first. Once we understand that, okay, we'll say, all right, never mind. Let's just represent it as the cosine using the Euler identity. In the Euler identity, you realize that Ej theta is equal to cos theta plus j sine theta. E minus j theta is cos theta minus j sine theta. You add the two guys up, and then the complex numbers goes away, leaving us with the real number. So you realize that by adding complex conjugate of things, we can throw away the complex number. And that is why complex numbers, that's why you'll see complex conjugate everywhere, because we need to throw away the complex part. So you see, if I want to get cosine theta, all I need to do is add this guy to this guy. But the inside theta is not so simple. It's pi over 4n minus pi over 2. So it's pi over 4n minus pi over 2. This guy minus pi over. So that's why students are confused. This minus will affect this minus. So now you see why one of them is a minus phase and the other one is minus. Then minus becomes positive phase. All right, so now you see this guy. Okay, once you have this guy, then we'll realize that this is the expression of sum of complex exponential for a cosine. And now you will look at the exam question. This little part will finally generate exactly like this expression here. Of course, slightly different values. Now, once you have figured out that this is the complex exponential, two of them, then where are they sitting? They are sitting at pi over 4 frequency. Okay. And now we find that we have to locate where is pi over 4 radian per sample with respect to omega naught. And then in this example, omega naught is equals to pi over 4. That's why k equals to 1. What about a over 2? See, this is a over 2, the magnitude. What about the first phase? Minus pi over 4. So this guy is minus pi over 4. The second guy, a over 2 at frequency pi over 4. And where? Which pi over 4? At the minus pi over 4. So that's why this guy is at minus pi over 4. Or we sometimes call this C minus K. Okay. So now you figure out we have C0, 1, 2, 3, 4 until n minus 1. We can also have C0, C minus 1, C minus 2 until the other side. So you study this example very carefully, and then you will be able to do part of the question in the exam. Right. Now, what about the magnitude? The magnitude is always a mirror image of each other, and the phase is a odd image of each other. And now we figure out all the values of CK for k equals to 1 and k equals to minus 1 in this example. So this question is very tricky, right? This is a 9-mark question. The first part is that you need to convert xt to x of nt, and then of course x of nt, you throw away the big T and it becomes x of n. Then you got x of n, and then once you find the x of n, you're going to apply 16-point DFT. That number 16 is for you to figure out that big N is 16. And then you have to go 2 pi over big N is 2 pi over 16 is pi over 8. You have to figure out pi over 8 is the small omega naught. And now you have to find what is the index K that is of interest to this frequency as well as to the DC frequency at the digital frequency part. So this question is not easy. It requires you to understand a lot of things. And finally, in the last question, I'll show you where is the answer. When is DFT used and its relationship? You can find the answer in the lecture notes here. Okay. So to understand the last part of the questions, you need to go to the DFT lecture notes. And then within the part, we are going to interpret the DTFS and the DFT. Okay. So the answer is actually this is an essay question. So you have to understand all this part of it to understand what is the relationship of DFT and DTFS. Let me see if I can find this for you. maybe you can interpret it here. Yep, this one. Okay. Now with that, I'm going to pause